பேசுறது கேக்குதா? ஹலோ, கேக்குதா?
சார் கேக்குது.
ஓகே, ஃபைன். சாரிப்பா, இந்த மாதிரி இன்டர்நெட் வந்து இன்டரப்ட் ஆகுறதுனால நடுவில் கட் ஆகி போகுது. நம்ம அவ்வளோ சீக்கிரம் அதை நம்ம முடிஞ்ச வரைக்கும் நம்ம முடிப்போம். ஓகே, ஓகே, ஃபைன். ஸோ இதான் ஈக்குவேஷன். திஸ் இஸ் த ஈக்குவேஷன் ஃபார் த லீனியர் சர்ஃபேஸ். எல் இஸ் த டைரக்ஷன் கொசைன். நம்ம அந்த கர்வுக்கு நமக்கு ஒவ்வொரு கர்வும் டைரக்ஷனுக்கும் ஒரு கொசைன் வேல்யூ இருக்கும். L is the direction cosine of the particular curve developing along the x coordinate. M is the direction cosine on y coordinate. N is the direction cosine on the n coordinate. So likewise, this is the theme. Finally, we can develop this. The linear surface. The result of the linear surface is a plane surface. A plane surface like this. This is the plane surface we can generate, and this is u, and this direction is v, u and v, and this is 0, 0, u 0, 0, right? This is 0, 0, and this is this point is 0, what's it? Sorry, 1, 0, because this is u and this is v. This point is 0, 0. That is u0, v0. This point is u1 and v0, and this is here u0, v1. This point, and this is both 1. U also 1 and v also 1. So like this, we can generate a plane surface, and this plane surface again we can represent with 3 points. So we can represent with the 3 points. Point 1 here, P1, P1, P2, and P3. So again we can represent these plane surface with the 3 points, P1, P2, and P3. To represent these plane surface with these 3 points, next slide will give the equation, right? How to represent with the same this plane with this P1, P2, and P3. So this is the same surface. The same surface can be represented with the point P1, P2, and P3. So each plane having the coordinate points of x1, y1, z1, x2, y2, z2, x3, y3, z3. This is x1, y1, z1, x2, y2, z2, and x3, y3, z3. So then we are developing the equation. This is the equation we are developing to represent this planar surface with these 3 points. So this is the equation. Okay, this is the equation. So by simplifying the equation, you will get this form: x of u LdV. This LD is this one, x3 minus x1, y3 minus y1, z3 minus z1 is nothing but direction cosine into the up to which distance it is developing. This is the product of direction cosine L into D. Direction cosine into how much of distance it is developing. This L into D is equivalent to this x3 minus x1, and the M into D is y3 minus y1. Z3 is N into V1. Like this we can generate. So we can represent a planar surface with only 3 points. Also written 3 points. This is the extension of that. You can remember this equation. So if anything they want to write about the linear surface, subsurface means just explain about what is the equation involving in this. Okay, and you can draw the planar surface diagram like this and mention the points and write the equation. Enough for this, right? And step to surface, again we can go for cylindrical surface. So we can generate, already we have seen many from the Swift based mechanism of Swift. We can generate cylindrical surface, conical surface, and so on. And this is the equation. So if we want to develop a cylinder with the axis of Z, okay? So axis of Z. So you want the cylinder you want to generate like this. Okay, the radius. If the radius is R. This radius is R, and the x-axis. This is the axis. Axis of the. This is the axis of the cylinder. This is the cylinder of z-axis. This is x-axis and y-axis in the opposite direction. This is z-axis and radius of R and height of h. This is height. This is height. Okay. Height is along the z-axis, forming along the z-axis. So if you want to develop a surface, a cylindrical surface like this, so this is the parametric equation. R into cos into 2 pi u and R into sin into 2 pi u, and Z is h into v. Actually this is not v, w, this is the direction, v direction. This is not w, it is v, h into v. This v is the direction cosine, right? So this is the parametric equation to represent for the generate a cylindrical subsurface. So we can conclude this session now here. So I hope you can understand these basics of how the surfaces, general form of surfaces, how we can represent some general surfaces. Now in the next class, we will go for how much of free form surfaces, mostly cubic surface, Bezier surface, and next one is B-spline surface and nuts. This surface, we will see how we can generate these surfaces and how we can represent the surfaces mathematically. These cylindrical surface, surface, everything have some, they are not free form surface. So it has some specific boundaries. They have some specific boundaries and limitation. But what we are going to see, but why have I have given these surfaces as introduction? So without the understanding of these standard surfaces, plane surface, cylindrical surface, conical or cylindrical, without understanding about how these standard surfaces getting generated, you cannot go and you cannot understand how the freeform surface equation is actually developed. So without understanding of the standard surfaces or introduction about the standard surfaces, you cannot go with the freeform surfaces. Mostly the swept surface. Here I am saying the swept surface. Very important. So we can, in the freeform surfaces also, we can use these swept concept. The swept concept it contains a generics and the directrix, and the generic is following a profile of a directrix and form a final path. This is maybe I can say this is the core of surface generation. So even the curves also you can see different curves, Bezier curves and B-spline curves. We can follow the curves with we can draw the profile, and on the profile we can draw the B-spline curve, and we can draw the Bezier curve. And if you give any direction, you can generate the curve along the direction, and you can get the surface along the direction. So if you understand the swept surface concept, then you can develop many surfaces in your mind. You can easily understand how the surfaces are getting generated in whatever surface you are getting generated. If you understand the concept of swept surface, the core of this session is understanding about the swept surfaces. Okay, I already know even the standard the standard this is the standard form of surfaces, but also we can understand or interpret with the help of the surface concept. Okay, I have already explained. This is a plane surface, even though you can consider this as a generatrix curve, and this is the directrix curve, and this genetic curve is developing along the path of this directrix curve. Like this, we can understand. We can apply this swept surface concept in the free form surfaces like our cubic surface, helmet, everything. So next class we will see detailing about what's it, the special free form surfaces. Okay. So thank you about. So good day. So thank you for participation. Right. Thank
Yes,
you.
sir. Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thanks.
Thank you, sir.